Russia has deservedly been getting a lot of bad press lately, but today I want to talk to you about one of the coolest things that's ever come out of the world's biggest country, Tetris. This classic 1984 arcade game consistently ranks among the most beloved and popular video games of all time. It's so addictive that psychologists have even studied the weird way that you start to hallucinate falling blocks after you've been playing the game for too many hours. This week we'll be kicking off a new tutorial series where we teach you how to build this amazing arcade game brick by brick. Along the way you'll learn how to use color detection to scan the play area and how to use Scratch's stamp tool to draw and update our game screen. Big applause to Chromeworks co-op student Quang Lac, who did all the coding for this very complex project. Let's get started. As usually happens with these tutorials, we'll be starting with a starter file, which is a file that contains all the graphics and sound effects you're going to be using to make this particular project. We're just going to save you the trouble of having to reconstruct all those little tidbits so you can focus on the coding part. So this is the starter file for Tetris. You can see that we've got a bunch of sprites in here that contain our famous geometric falling blocks from the game here. Now the construction of these guys is done very rigorously if you want to have a look at a really close-up look at this block. Now remember that each of these gray and white guide squares inside Scratch represents 4 pixels on the screen, so I'm zoomed in quite close here. So the width of the entire block, counting this little gap around the edges, is exactly 20 pixels. So the block itself is 18 pixels and then a 1 pixel buffer around the edge to separate these blocks from each other. Now that size is going to be important because as we're falling, we have to make sure that these blocks stay aligned with each other so they fit perfectly. So we're always going to be dropping these guys by exactly the size of one of these squares, which is 20 pixels. So when we're falling or manipulating any of these characters on the screen, we always want to make sure that their movements are in 20 pixel increments. And we'll be just looking at that in just a second. Okay, let's jump over to our backdrop where you're going to see some familiar scenes if you've played Tetris in the past. Here's our game splash screen. This is copied right from the original arcade game, 1988 Atari games. And we've also got a backdrop here that is also lifted from an earlier version of the game. We're going to be filling in the statistics area here in a future lesson here to keep track of the number of blocks that have fallen and the number of lines. So all of these areas here on the screen where information is supposed to be gathered, they're all going to be filled in later. But for today we're going to focus on making these blocks start to fall down off the top of the screen. So that's what we'll get to next. To start off the game, let's start coding inside the backdrop here. We're going to make sure that we're on the title screen when we click the green flag, so let's switch to that backdrop. And we're just going to click on this to start our game. So unlike other games where we've been using thumbnails lately, it's something that I've been doing a lot. In this game, we're just going to hide everything that that is part of the actual gameplay so that we're just looking at the backdrop at the beginning, and then we're going to trigger stuff when we click on the screen. Alright, so the first thing we're going to want to do as well as switching to the title screen is we're going to want to start that iconic theme music. We're going to use a play sound until done, and I've already got the Tetris theme set up in here. And as you can see when I click the green flag, who hasn't heard that music? So I'm going to disconnect this for now. We're going to hook this up again at the very end, but I don't want to be listening to this and have it competing with my voice as I'm doing the teaching here. So I'm just going to leave this at the side. If you want to hear this theme song 2,000 times while you're coding the project, then hey, that's your business. All right, so in addition to that, we're going to be waiting here for when the stage is clicked. Now, if we click on the stage during the gameplay, we don't want to accidentally restart the game. So we're going to put an if statement here that says when it's clicked, we're going to check and make sure that backdrop number is number 2, which is the one you're looking at right now, the title screen. So if we are playing the game, our backdrop will be 1, and in that case, this click on the screen isn't going to do anything. So if it's clicked, Then we're going to broadcast a message that says getting ready. And this is going to trigger a few things across the entirety of the game here. So we're going to be affecting a couple of blocks, and that's why we're doing a broadcast rather than simply just initializing our variables and stuff here. We do have a little bit to do under getting ready inside this sprite though. Let's have a look here. So once that click happens and this getting ready message goes ahead, then we're going to switch our backdrop back to our gameplay backdrop. So we're going to switch to Tetris backdrop. Then we just have to initialize some variables here. These are all global variables. This one is called time, and it just reflects how fast the game moves. As the game continues, things are going to get faster and faster and faster, and this time variable is what's going to keep track of it. We're setting it to 0.80, which gives us a falling rate that's about on par with what you would expect of the arcade game. And then, as I said, that's going to speed up. Our initial score is 0, our initial level is 0. The line, we'll talk about that variable in a bit, is 0 as well. And that is an indicator of where these blocks are, so there's a bunch of invisible lines across the screen here, and that's how we're going to tell how high or low things are on the screen using that line variable. And we've got a stats variable here too, which we're going to be using to keep track of these statistics here, how many of this kind of block have fallen and how many of this kind of block, etc. Now that is a list variable because we've got 7 different variables to keep track of here. Rather than creating a separate variable for each one, we're instead going to put it all onto a list. We're going to be working with this a little bit more in the subsequent parts, but while we're in this getting ready, we might as well finish it up here. So we're just going to add 7 zeros to this list here just to initialize the list, and then we can change any of the individual lines on it. So once this is done, you'll see if we go to our variables and show stats, you'll see it's just a list with 7 items on it, all of them at 0. And that's going to keep track of how many of each kind of block have fallen. We really don't need to worry about that right now, though. I just don't want to have to return to this block here. Alright, so the game's actually going to get going after this initialization is done here with a message here that says broadcast new block. And then it's going to command the actual main blocks that are falling off the screen here to get moving, to start moving down the screen. First, though, I want to go back to this sprite called next, where we have to initialize something for reasons that are going to be obvious in a second here. So this next is just the sprite that appears here to preview the block that's coming up next, and that's going to be falling down off the screen after this one is done. Now that's important strategically in the game because sometimes when you're positioning something, you have to have a sense of what's going to be coming next down the line, or you could paint yourself into a corner. Anyway, so if I show that invisible sprite here, you can see that we're set up with a next block here. And it's positioned correctly already. So all we have to do is we're going to hide it at the beginning of the game and just initialize it. So we're going to tell it to wear one of 7 random costumes. There's 7 costumes here representing all the different blocks that could potentially fall off the screen, and there are 7 of them. So as soon as I click on this, you can see that my next block switches to a random selection from those available blocks. Okay, that's perfect. So that's initialized, and we're going to be referring to this costume over in our block sprite. So this is the main sprite that gets stuff falling off the screen here. And you can see when I click the green flag, we're going to be hiding it because, again, we don't want anything visible at the start of our game. And then we're getting that new block message that's coming over from the backdrop. So the first thing we're going to do is, as I said, we're going to make reference to that next block that was selected over in the sprite called next. This is a reporter block, which we used quite a few times in coding, a really handy little block that tells you information about what's happening in other sprites or in the backdrop. It says backdrop here or stage here by default, and you can find other information about the stage. We want to look at a sprite though, so the first thing we want to do is, so if you manipulate this, you're only going to see stuff that has to do with the stage, and this is one of the confusing things about this block. So since we want to find out about a sprite here, we're trying to find the name of a sprite, we have to first change this right one here to the name of the sprite we're looking at. So we're going to go next, and now we have a totally different set of options here in this left-hand panel, and from there we're just going to grab costume name. and that's what we put into the switch costume here. So it's just going to pick up the name of the costume that is in this position here, and it's going to force this sprite here to change its costume to match. So as soon as I click on this sprite, you can see we're going to end up with a blue horizontal block here. That's exactly what we want it to happen. All right, we're going to take that information, what costume this guy is wearing, and we're going to put it into a separate variable here called holding. So we're just going to make it match the current costume name. We could theoretically have put one of these in there and it would have done the same thing as well. So we're just going to store the name of that costume in a variable. Then our invisible sprite's going to show, and we're going to position to the top of the screen, which is right here. You can see with the way these blocks are centered, they've been placed very, very carefully so that the center of gravity that they're going to be spinning around is always right at the center of the screen here. So in this case, because we've got a big block, a big horizontal block that has no top half, we're actually leaving the top half of this blank. But if you look at a bigger example, like this one here, for example, you can see that it's perfectly centered. Some of these blocks don't really have a center, but we've tried the best that we can to have it pivot around a common point. And you can see all the different costumes of this guy reflected spinning in the same way around that orbital point. Okay, let's go back to the code. So we're going to set this guy up to start at the top of the screen here, and then he's going to start the process of falling. Okay, there's one more variable we need to set up here, and this one keeps track of the costume number of whatever we're holding right now, and so that variable is called costnum. And again, we're going to match that up not to the name of the costume, but to the number of the costume we're wearing right now. So these don't show up until a little bit, but it's important to get them set up right now. All right, we're going to broadcast a message here called change. So every time a new block gets set up, we need to take this next block and change it to whatever the next block is going to be. So we've already grabbed the existing sprite off of this next, moved it up to here, and now we need to generate a new guy to go here. And that's what this change message does. So let's go back to our next sprite here, and you can see that when I receive, we're just going to switch our costume back to a random one of those 7 costumes again. We've also got a show block here and a positioning block as well, which isn't strictly speaking necessary, but if you do accidentally move this sprite around, it's good to have something that will snap it back into position again if you're playing it in editor mode. Okay, and so we're switching to a random costume, and now we're ready to go for the next round. Okay, now our blocks are going to start falling down the screen, and we're going to make that event all happen inside of a custom block. So we've gone ahead and created a custom block called falling, and I'm going to trigger it here with this red block that we've created. You guys will remember that we can make custom blocks by just going to the red custom blocks area, clicking make a block. Now there's a bunch of options here, but we only need to put in the name of the block at the top here. So we've got our falling. Now we need to define it. So when we created this block, we created a second block here that defines what it means to be falling. And that is right here. So this custom block called falling is going to control the movement of our blocks as they go down the screen here. There's a variable called lock, and that's going to determine whether we're able to move these guys at all. If you remember the original Tetris game, you know that we can control these blocks, make them move left or right, and spin as they're falling down. We can also accelerate their motion downwards by pushing on the down arrow key. So all of that is possible until it lands, and then we have a split second to jiggle it around a little bit. At that point it locks and no longer will accept your input, and that will trigger the next block falling, and then we'll be able to control that. So at some point you lose the ability to monitor these blocks and manipulate them on the screen, and that's what that lock variable is going to indicate. So we're only going to be able to do stuff to this block while it's unlocked, while the lock is set to 0. So we're going to initialize that at 0 as soon as it starts falling. And then we're going to get into this endless loop here that's going to continue until the block is locked. And this is where the actual falling is going to happen. We're going to fall a little bit and then wait a delay time that's based on that time variable that we set up in the backdrops category. So this is going to get faster and faster as the game progresses. So this is the main loop of the game here, where blocks are falling and you're controlling them. And we've got this another custom block here called check position, and so the actual downward motion is going to be controlled by that. Let's go ahead and define that block here, check position, and let me show you how that works. So if the block is unlocked, we're going to start it falling down the screen here. So we're going to change its Y by 20. Remember, moving it down by 20 will move it exactly one set of blocks down the screen here. You can see that it's very rhythmically going down the height of one block. Every step it's moving along the way here, and that's exactly the way we want it, so that when it reaches the bottom, it's perfectly aligned with the bottom of the screen, no matter how it is tilted as well. So even if it's rotated, it'll still line up perfectly with the bottom of the screen. Okay, so we're moving down the screen here. All right, we're actually at a point where we can test this now. Let's go ahead and start our game. And you can see that our block, which was randomly selected, is falling down the screen here. The only problem, of course, is that it's going to keep falling. There's nothing here to tell it to stop at this point. It's going to go right off the edge of the screen. So let's go ahead and fix that next. So if touching, so underneath this first if statement here, now this is already inside a loop. Normally if there's an if statement, you need to put it in directly inside a loop here so that it'll keep checking over and over again as the object's falling. But since we're already in a loop here, we're just going to keep checking these if statements once inside the custom block here, and then it's going to come around and rerun this custom block every time we go around the loop. We're waiting for this lock to equal 1, and that's what's going to be happening inside this if statement. If we're touching this kind of light blue color here, we're going to be using a lot of color sensing here, and that's something I don't do in a lot of projects, but a project like Tetris really kind of demands this sort of approach. So we're checking to see if we're touching one of two colors. One is the color of the edge of the screen here. So this is this color here. We're also checking to see if we're touching gray. And that gray actually reflects the color at the edge of these objects here. So it's this color gray. And this will let us know that we're either at the bottom of the screen or that we're landed on top of an existing block here. And that'll figure that out. So if we are touching it, it means we've already overlapped with that block, which means that we're going to have to move back up again and correct ourselves. So that's why we're moving back up by 20 pixels here, which will move it to the position it was at the last moment before it started, before it collided with the other object. Okay, our sprite has reached the bottom of the screen now, and it's popped into the proper position where it's going to be its resting place. Now we're going to end up taking the sprite and moving it back up to the top of the screen again. But before we do, we have to kind of save its position there so that it joins the grid of other blocks that have been placed along the bottom of the screen. To do that, we're going to use the stamp tool, which is available under the pen add-on. You guys will remember that if you click at the bottom left button here, you can load this pen add-on that gives you a whole bunch of drawing tools. And one of them is a tool called Stamp. And all Stamp does is place a version of the sprite down as a graphic instead of as something that's movable of the sprite. So it just basically adds to the background of your object. If, for example, we stamp this sprite right now just by clicking on this block, you can see that when I move the sprite out of the way, there's still an object there. Now it's not a clone, it's actually an image. And the only way to get rid of that is by doing an erase all, which will blank out anything that you've drawn on the screen here. So that stamp's going to come into play here, but we don't want to use it inside this sprite. What we basically want to do is use this sprite that's on the bottom of the screen here to detect how we're going to stamp this object. So let's place this broadcast now, and we're going to pop over to a sprite called Tile. So this sprite is one of a whole bunch of squares here. Each of these squares is exactly the same size as the individual squares that make up these blocks. So because we placed all these very, very precisely, we can actually use these little individual shapes to try and place down to duplicate basically what's already on the screen here. So our mission is going to be to take these 4 blocks that are down on the screen here and get each one of them stamped down. And we're going to do it through a process of just placing one of these squares down on the screen, starting at the bottom right here, and we're basically going to check what color is underneath here. Is yellow under it? No. Is magenta under it? No. Is blue under it? No. And finally it's going to say, well, I guess I should put a black square there. Then it's going to go to the next spot on the list here and keep doing that over and over and over again until it gets to one of these yellow things. And now when it asks itself, hey, is this a yellow one? The answer is yes. And then its instructions will be switch to a yellow costume and stamp yourself down there. Now this is important because as we're placing these guys down here, we're going to need to be able to check it out on a line per line basis. So we need to know that this entire line of guys is filled. We can't just delete this sprite because that will delete 2 lines. So that's why we're converting this into an image so that we can look at it just one line at a time and check and see whether this entire line is filled with colors or not. And this is going to form the real basis of how the intelligence of this game works, allowing us to delete certain sprites, or sorry, certain graphics when we need them to, without actually having to tear these graphics apart, which isn't something that's really possible in Scratch. So this will make a little bit more sense as we implement it. So we're inside of the tile sprite now, this detector sprite that we're going to use to paint this background for us. And we're inside this message here called stamp block, which we've just sent over from the block sprite. So as I said, we're going to go right down to the bottom right of the screen. Let me demonstrate for you. I'm going to take this sprite, which right now is wearing a yellow costume, and let's make it visible. So right now it's at the top right of the screen, but we're actually, when we click this location block to go to an X of 90 and a Y of minus 50, it pops into the exact right spot we want it to be at the bottom of the list here. And so we're going to, from here, start checking to see what colors are underneath us. And that's all inside of this stamp custom block that I've created here. Now, one of the reasons we want to do this inside a custom block is this is an exhaustive process. You can see we've got a repeat loop of 10 and a repeat loop of 17 here. So we need to run this routine 170 times. Now, in playing with this, it turned out that it took actually a second or 2 or maybe even more for this whole process to be completed. And when we make this a custom block, we have an option to run without screen refresh. What this does is basically supercharge the process so that we don't have to look at graphics changing on the screen, and we're no longer locked into the 30 frames per second frame rate that Scratch forces us into. So this will supercharge little parts of your program and make them run super quickly, which is very important when you're doing something complicated like this stamp sprite here. Now this is a very complicated sprite, and the colors have to be exactly right. If any of these color values is even a little bit off of where they are on the original sprite, then this is going to mess up. Of course, we got these colors by going to our sensing blocks and basically clicking on this button here and then using our eyedropper tool to go over and select like the yellow from this block here. And that way the color value we get, which is like color of 16, saturation of 100, brightness of 100, we can nail that down exactly inside this spot here. Now, I'm going to save you guys the trouble of redoing this big block of code. I'm going to give it to you in one piece. So if you look at your starter file, you'll actually find a finished version of this stamp. It's just, there's so many pieces in here, and you're going to be frustrated if this doesn't work properly. So I think you should just borrow my code here, and we're going to walk through it here just so you understand exactly what's going on here from a coding perspective. But I'm going to save you the trouble of actually building this because it's just going to take too much effort, and there's too many places where you can nest one thing in the wrong place that's going to mess you up. So you can see here that the series of loops here, and inside the inner loop is a whole bunch of nested if-else statements. So all we're doing is checking to see if something is true, and if it's not true, we're checking to see if the next thing is true, and then the next and the next. And the way that this works, though, is it's a little bit more efficient than putting a whole bunch of if statements. I could have put this in about 7 or 8 different if statements, but then it would have to check each single object. So what's happening here is if it's a purple one and it actually switches to purple, then it doesn't have to do all the rest of this. So this is a much more efficient way to code a little bit of programming here inside where there's a bunch of if statements, and get it to do it more efficiently. So if the color we're searching for is cyan here at the bottom, for example, then we are going to have to go through all these if statements. But odds are that this little bit of code here is going to stop running much earlier than it needs to, and that's going to end up saving us some precious time and making this program run a lot faster. So what's happening here? Let's ignore the outer loop right here. So we're doing something 10 times here. What we're doing is we're checking to see if the color is purple right underneath this sprite that we have created here. So this tile sprite, by default, it's black here, like this, I believe. Though I'm going to keep it a visible color so we can actually see it here. So we're going to look underneath the sprite and see if it's touching the color starting off with yellow. So if it's under color yellow, that must mean that this block is one that's sitting in this area, or this kind of block, the yellow block. So we'll stamp a little yellow square here. It will switch the color to yellow, or it's starting with purple, and it'll switch the costume to purple, and then once it goes through this loop and determines what color is under there, the final else here is it'll just switch to a black costume. If it can't find any of these colors, it'll just color it in with a blank. So we're wearing the right color costume now, and then we're going to show this block, which I guess was hidden up until now, stamp it, and then hide it again. Then we're going to shift over 20 pixels to the left, and we're going to do the same thing all over again. So once we're done this loop 10 times, this inner loop, and we've stamped down anything we need to stamp down here, then we're going to move up to the next row, which is 20 pixels higher than this one. Then we're going to move 200 pixels to the right all the way across the screen here, and then we're going to start again with the next row. And we're just going to keep doing that across the entirety of the image here. So no matter how complicated a structure we've got here, it's always going to recreate it by looking at what's underneath here and then stamping on top of it. If there's an existing color already stamped, it's just going to stamp on top of it all over again, which will mean no change to it, basically. All right, let's click the green flag right now, and we'll see that in action. So we'll start our program and let our object fall. We're not able to spin it yet, as you might remember. All right, so that's landed in its place, and you can see that something's happened here on the screen. So we know that this has worked because when we pick up this sprite, now we're going to be sending the sprite back up to the top of the screen to change costume and then start falling again. But when this sprite leaves, you'll see that it has left a ghostly version of itself on the screen. Actually, it's continuing to fall here since we haven't set this up properly. And you can see that as soon as we do that, it's trying to place new stuff. Now everything's messed up here because our objects are off of their grid. But anyway, so you can see that the stamping process is working exactly the way that we want it to, and it's made a perfect duplicate of this shape, which is exactly what we wanted to do. So that's great. So now that this stamping process is finished up, there's one more thing we have to do in this tile. We're going to do one more run through of this list here, checking to see if we've completed an entire line of blocks here. And in that case, we're going to go through a routine where we delete all these blocks and then shift them one further down. Now that's a whole other story, and that's a bit more complicated, so we're going to save that for our next installment. For now, though, I just want to reset this. Now that our object is stamped properly, we just want to go back and create a new block at the top of the screen here. So I'm back inside the blocks sprite here, inside the check position custom block. So as soon as we're done this stamping subroutine, which is over in the tile sprite, now we can lock this guy up, and that's going to stop this repeating loop here. This is repeating, it's checking the position over and over again and making the guy move down until this is locked. So now that this is locked, this whole branch of the program is just going to come to an end, and we are going to want to create a new block. Now the creation of the new block happens at the end of this other custom block that we're going to add next week called check line. So we're going to temporarily put it here. So when we're done stamping our blocks, we're going to do a little pop that signifies that the next guy is ready to come up. And so this new block is not going to be here in the end, but we're going to put it here temporarily just to keep the program moving forward. So let's add a little comment here. Keeping ourselves honest here. All right, but with this in place, you can see that things are working quite nicely. Now we're still not able to move these blocks, but we can watch this block moving down, stamping itself, going back to the top of the screen, moving down, and then stamping itself into a new location, and we'll end up getting a little tower of blocks here. Let's just fast forward through this here. And you can see here that we're building an increasingly discombobulated tower of blocks here, and they're all being created with stamps. These aren't clones or objects, they're just graphics on the screen here, but the Scratch is able to interpret it all based on the color, and this is working beautifully. Okay, so this is in good shape now. That's all the time we have for this week. Next week we'll be back to show you how to use keyboard controls to spin your objects in 2D space. And we're going to create a new scanning routine that checks to see if we finished a level so that we can erase it and move all the blocks down one level. All that and more coming up. If you're enjoying this content, please leave us a like and drop us a comment if you can. And if you haven't done so already, we'd love to have your subscription. In the meantime, keep on scratching. We'll be back next week. This tutorial was produced by Chromeworks Technology. For more Scratch tips, tutorials, game reviews, and interviews, subscribe to this channel and make sure to tune in to our weekly live show, Saturdays at 10 a.m. Eastern on YouTube.